Okay, rules of logarithm. I'll have camera rules here. Okay. I'll use this one. Okay, log of x times y equals log of x plus the log of y. And I'll mention this is inverse to the property of exponents. Like when you add the exponents, you get the product of two things, right? Here, when you add two logs, you get the log of the product. So this is related to this. You have an addition here, and you have a multiplication here, just like you have an addition here and a multiplication here. That doesn't look the same, might not feel the same, but I'm just pointing out that there's a direct relationship between this and this. I could explain that using the graph. Okay. Ask you to check your masks. Somebody have the mask a little bit low. So you have the product. Okay, the log of the product is the sum of the logs. Okay. You just gotta start using that. You gotta do a bunch of problems and apply this rule, and then remember it. So of course, when you take a test, you know what rule. Okay, another one is I'll just use x and y. The log of x raised to the y is y times the log of x. And of course, we know that if you take a power of a power, you have a power becoming a power associated with a multiplication. So you've got a power here, and there's a multiplication by the power. Now, it's not an exact analogy, but it's just related by the fact that the log and the exponential functions are inverse functions. Now, this applies to any log to any base, which means it would apply to the natural log base 2, or the log log, which is a log base 10. That's about it, except for the last one. Which we saw last time and which you used for your homework. Okay. Now with these three laws, we'll just do this with a couple of numbers. Log of 5 plus the log of 10 equals what? Go ahead and write out your thinking on that. Okay. Log of 5 plus a log of 10. You see that this form matches this, right? Okay. I don't have a base on the log, so this is automatically a base 10 log. If I had a base 2 or base 6 or a natural log, it would apply just as well. Log of 5 plus a log of 10 equals what? Well, you look over here. It's the log of x plus a log of y is a log of x times y, right? It's a log, so you got to write down that log. And then it's this times this, which is okay. Make sense? Now, if you want to do this on your calculator, you can. Okay. You could verify this by doing this log, get 1.6 something, and then do this log, which is like 6, and this log is 1. And this log will add up to this. Okay? And of course, 5 times 10 is 50. So if you were to punch in log of 50 and then punch in log of 5 plus log of 10, you get the same result. Okay? How about this? Log of now, I've used x and y up here, but now x is going to be x minus 5 instead of y, you're going to have x plus 7, right? Looks pretty good, but let's write this out real carefully, okay? Now we know that to avoid confusion, I'm writing this down using A and B. Probably shouldn't use A and B. I should probably use A and C since B is a typical symbol for the base. It's that. Okay. Just for reference, I've written down the rule, but since I've got x's here, I don't want to use x up here. And since I'm not using x, I'm not going to use y. I'll use A and B, but it's the same rule, just with different letters. Everybody understand that? So now we can say that A is your x minus 5, and B is your x plus 7. Okay. So now this equals well, log of A times C is log of x minus 5 times x plus 7. I'm going to correct this and lower the camera a little bit to avoid the watermark. Okay, so just writing out the law again and being very explicit about what A and B are, we can then see that the log of A times C is this, and that's what we're going to write on the right-hand side. Now, you can then expand that, and in general, you would maybe want to keep it factored, maybe expand it, but you should have the ability to do it either way. That's going to be, when you expand it, it's x squared plus 2x minus 35. You agree? We need to check masks again. Well above the nostrils. Okay. Okay. Let's look at a few more examples now. I said I was going to regret lowering the camera. I'm going to have to, excuse me for a second, because there are a couple of people that might be wanting to do this through Zoom. It'll take me just a second. Well, maybe as much as a minute. Takes Canvas a second to come up, but there it is. It will take just an extra second to look and see. And now I've got to remember to keep an eye on the screen if somebody wants to get in. Okay. Oh, geez, it was recording while I was doing that. Well. Okay. Let's do the log of x plus 3 to the 4th. Okay. Well, we're going to use the rule where you have a power. So we identify that this expression is in this form, right? Now, probably a little confusing that I use x and y's in these expressions. I think that's causing some a little bit of trouble. So I get rid of the x's and y's. I think when I use A, B's, C's and stuff, a bit more confused things with some of the other things we looked at. I'm thinking that this is a little more confusing than that. So I'm going to do it this way. I'm going to use capital letters, which I thought of doing in the first place. I went with x's and y's, okay? I'm going to use capital A and capital B. Okay. So just to avoid confusion between capital B and lowercase b. My mind and use capital C. So there are the rules without symbols that would be easily confused with your X's and Y's. Now we can identify this, and let's number these rules. Okay. Number 2 matches this. If A is x plus 3 and C is 4, then we have x plus 3 quantity raised to the 4th power, which is exactly what we have here. Okay. So I'm going to write it out. The log of A to the C equals C log of A. The log of the quantity x plus 3 raised to the 4th power equals C, which is 4. And the log of A, and A is your x plus 3. Okay. Well, let's try another one. Let's try the log of x squared y cubed. And I'll give you a hint. You're going to have to use 2 of the rules. But just start by using the one you think is most straightforward. Okay, now you want to be very careful. If you're not getting these pretty quickly, you want to be careful to identify your A and your C. Okay? Each rule has an A and a C. So this is log of A times C with A equals x squared and C equals y cubed. Okay? This is the form. If you have any trouble at all, write out A equals C. Okay? Then say, well, then that's equal to log of A times C equals log of A plus log of C. So the log of A times C, which would be x squared times y cubed, equals log of x squared plus the log of y cubed. And then you see, so you can apply the second rule. Okay. So put it over here. Log of x squared is a log of a to the c. Okay. Identify a and c. Now a equals x, c equals 2. So log of a to the c equals c log of a. So it's a log of x squared. Because a is x and c is 2 equals c, which is 2 times the log of a. Okay. And then also the log of y cubed. Again, down near the water mark. Log of y cubed is 3 log of y. Thus, log of x squared y cubed is 2 log of x. Plus 3 log of y. Okay. So again, if you're not getting these pretty quickly, write it out the way I've written it out here. Follow the logic, match it up with the rule. After you've done that half a dozen times, you'll know it. Okay. Now, there's another rule. I'm going to call this rule number 2.5. It's not 2 raised to 1/2. It's 2.5. Okay. This is, oh, I'm sorry, log number 1 of it. If you divide, well, if you multiply a and c, you get the log of a plus the log of c. If you do the log of a divided by c, you get the log of a minus the log of c. See where to see that, so there we go. We call that rule number 1.5 because it's really just rule 1 and 2 combined. A divided by c is a times c to the -1. And the log of c to the -1 is negative log of c. Log of c by this rule. Now, if you don't see that instantly, it's okay. You can regard this as a separate rule. I just regard it as another instance of the first rule. That might be a little complicated. So we have this secondary rule. Okay. I call it rule 1.5 because it's really just this one. So what's the log of x plus 4 divided by x minus 2? This is exactly. So now, how do you follow it? Practice it. Okay. It's a pattern and it's not a difficult pattern to get used to. It's just unfamiliar at first. Okay. And Ian's here. Okay, Ian can't hear me yet. We're going to give him just a second, okay? He's worth waiting for. There he is. Okay, Ian. Hope I didn't keep you waiting too long, but that's the first I've seen the request. We've done quite a bit already. You're going to need to look at what we've done, but let's just look at an application of one of the rules of logarithms. Okay. And some people need this explanation again. So I'm sure we understand. One of the rules is that the log of A divided by C is equal to the log of A minus the log of C. So if we have log of x plus 4 over the quantity x minus 2, okay, get the mass flow, please. And then this is going to be A because it's the quantity that's in the numerator. And this is going to be C. Don't make noise or identify because we're on camera. Although you're doing great. Okay. C is going to be your x minus 2. Okay, let's say that again. A is going to be your x plus 4. C is going to be your x minus 2. See how the form matches up. So that log of A over C equals log of A minus log of C. This is going to be the log x plus 4 minus the log of x minus 2. Now we've got a number of examples of other rules. And, here they are. If it was x plus 4 times x minus 2, that would be A times C, and we'd be adding the logs. Okay. Now we're going to do a couple more with exponents. And here's the rule for exponents. Okay, and that's it. These three rules, plus this one, which we reviewed already last night's homework. Okay, or the homework we did today. All right, now, hopefully everybody's got the rules written down, but I'll write them down as we apply them. Okay. Let's see where we are in the boards. Let's see if maybe we can go up this high. Unfortunately, can't remove the discrete units. I can't find too many. Let's look at log of x squared y to the fifth over z to the fourth. And while you're working on that, get that copy down. We're going to write the rules down right here in the center of the board. So that's the reference, okay? You don't need to watch me do that. You got them written down. If not, you'll see anything. Everybody got it written down? Okay, anybody doesn't have it written down, let me know. I'm going to block the board here with my people by. Focused. Focus worth a darn. Focused on me. And I'm right by the board, so why isn't it focused on the board? That slows me goes a little bit. Anyhow, there it is. Okay, so here are the rules. Okay, here's the expression. Now, I'm not going to write out well yet. Okay, this is the expression of there are a couple of ways you can do this. So I'm going to say this is a log of A over C. We've got a numerator and a denominator. Okay. Now you could also do it as log of A times C, where A is x squared over z to the fourth, and C is y to the fifth. Okay. But you got to get everything into the expression you have here. Or it could be A times C, where A is x squared, and C is y to the fifth over z to the fourth. Okay. So there's more than one way to do it. They all lead to the correct solution with approximately the same amount of pain. Okay. And it isn't that painful once you're used to it. So if we have this, okay, we use this breakdown. Log of A over C is log of A minus log of C. So the log of x squared y to the fifth over z to the fourth equals the log of x squared y to the fifth minus the log of z to the fourth. So A is this, and C is this. And the log of A over C is log of A minus log of C. We're sure that this is right. Now, I say that, but often I make little mental errors, write things carelessly. So is that right? Okay. We'll verify it. I believe that's probably right. Now, applying the first rule to this, because that's what we want to do. And I'm not going to write out all these A's and C's now, it kind of confuses things, and hopefully it came in late, you see this well enough. But the log of x squared y to the fifth by the first rule is the log of x squared plus the log of y to the fifth, right? You have x squared times y to the fifth here, and you're going to get log of x squared plus the log of y to the fifth. So that's the log of x squared plus the log of y to the fifth using the addition. Okay? Then it's got to be minus the log of z to the fourth. We could leave it that way for right now. Or we could go ahead and apply rule 2. Okay. The log of a to the c is c log of a. So the log of y to the fifth is 5 log of y. So z to the fourth. So what I said is correct. This is work on. Okay. So we can use the second rule already to simplify this, and that's about as far as we can go. Well, if we use the second rule here and here, 2 log of x, 5 log of y, minus 4 log of z. Okay. Now, you got to write out the A's and B's here. It's a good idea if you're still not getting these real quickly. Continue doing that until you can really see it. Okay. It's a pattern. You will pick up the pattern. But if you write things down without carefully considering the rules, you're not going to ultimately see the pattern. So it's a little extra pain. You have to write it all out with A's and C's. But it prevents you from getting the wrong idea. And it enhances the right idea until all of a sudden the pattern becomes something. Okay? And you get used to it, and then it becomes easy. Okay, now I hope I was recording that, but anyhow. Just briefly, log of this, we can regard that as log of this divided by this, which will then be the log of this minus the log of this, which is what we have. Then the log of this times this is the log of this plus the log of this. So log of x squared plus the log of y to the fifth. And the log of z to the fourth is 4 log z by the second rule. And then applying the second rule again, log of x squared is 2 log x, log of y to the fifth is 5 log y. You got to write it out with the A's and C's. Continue doing that until you see the pattern. Okay? Don't write down wrong things because that reinforces the error. Write it down carefully, correctly, and of course, in the open math. Okay, so let's go to this equation. And not everybody can necessarily see the equation. Here on Zoom. You might have a little dead space there. Here we go. Okay, this is an equation that says a log of some expression equals some number, right? We know from the homework we did for today, and which everybody did quite well, that you can convert this to exponential form. You can't get to x inside of a log, okay? Or you can't get to x if it's inside of an exponent, which is why we have these rules that take the logarithmic form and change it to exponential form, and vice versa. Have an exponential where your x is stuck up there in the exponent. Get it out of the exponent by converting to logarithmic form. And you've done that. Okay? You did that for homework. So we're applying the same thing you did for homework. Because x is tied up inside the log, converts to exponential form. And what you get, using the rule here, log to the base b of a equals c. A is a thing you're taking the log of, that's the x minus 2 times x plus 3. And c is a thing on the other side of the equal sign, which is 3. That gives you b to the c equals a. Well, b to the c. What's b? B is the base, right? It's 2. So as we did last time, you can write it down. B equals 2. A is x minus 2 times x plus 3. And c is 3. Write that down and then substitute that a, b, and c in here. You get c to the third equals x minus 2 times x plus 3. And that's just an algebraic expression. And if you understand the distributive law stuff, you see that this is something you can easily multiply using the distributive law. Okay? And let me emphasize, this is not x squared minus 6. It's not x times x minus 2 times 3. You've also got the x times 3 and the negative 2 times x in there. Okay? You want to write it out using the distributive law. I've seen too many errors with not the distributive law. You got to be very careful about that. We need to be beyond the errors. Okay? Otherwise, you got to keep stumbling. It's going to be painful. Don't want you that thing unnecessarily. Okay. So now we have 8. And if we multiply this out, we get x squared plus x minus 6. Now, how do you solve this? It's a quadratic equation. You put it in the standard form of a quadratic equation by subtracting 8 from both sides. So we're going to say x squared plus x minus 6 minus 8 equals 8 minus 8. So you have x squared plus x minus 14 equals 0. Then the quadratic formula. I'm not writing out the details because we've done it many times. Some people do fine with. Okay. That's going to be 1 squared times 4 times 1 times 14. All that over 3 times 1 is full substitution. That's negative 1 plus or minus square root of, and it's negative 14. Did the substitution, but I wasn't careful, right? So I got to keep an eye on it. But that becomes 56. And you add 1, you get 57. And you do prime factorization, you're going to get 3 times 19. Both of those are prime, so you're not going to factor square out of that. So something to leave it that way. But there's your solutions. Now you can approximate your solutions, depending on whether you want an exact or satisfied with the approximate solution. But those are going to be the solutions to this equation. Okay? And it's a straightforward process. Convert the exponential form because your x's are all inside a log. Okay? You can't get to it. You got to convert the exponential form using this rule. Having done so, you got something that's easy to solve. Just expand this, recognize you have a quadratic equation, put it in standard form, use the quadratic formula if you can't factor it. Okay? Or use a quadratic formula even if you can factor it, unless you're asked to solve by factoring. You always want to look and see if it's possible to factor, but usually in applications in the real world, you're not going to end up with a quadratic equation. Let's do one more real quick. Let's say we have make this log base 4. Now, what can you do with this equation? Well, we've only got less than 2 minutes. Try to let you get out of your time. So I'm not in a big hurry. Okay. We got a sum of 2 logs, right? Using this rule here, we've got log of A plus a log of C, right? Where A is x minus 2, C is x plus 3. Well, that's a log of A times C. So now we have log base 4 of x minus 2 times x plus 3 equals 3. We change this now, or now we're in the same pattern that we have here. Matter of fact, I've even still got the x minus 2 and the x plus 3 there. I've even got 3 on the other side, but I've got a different base, so we're going to have to do something. Okay? But this is now convert exponential form. X minus 2 times x plus 3 equals 4 to the third. Again, I'm using this rule. So that means that x squared plus x minus 6 equals 4. And now, let's move off the board here. We have x squared plus x minus 70 equals 0. Et cetera being quadratic formula. Do the same thing you did over here, except you're going to have a minus 70 instead of minus 14. Okay? So these things really can be pretty easy, and I think we've done pretty much examples of everything you're going to have to do in your homework. Okay? Naturally, as always, you have the supplementation of the open math videos, which can be very helpful. But whatever you do, don't solve these equations by going to Wolfram Math or something else. You'll get the right answers and you won't learn a thing. And when you get to the test, you won't know anything, okay?